Okay, so in this lesson we're going to continue talking about solving linear equations, but this time we're going to look at the multiplication property of equality. And so this is going to be part one of the multiplication property of equality. And in a previous lesson we talked about the addition property of equality. So let's kind of review the addition property of equality. So if we want to solve this equation, x plus 3 equals 7, this linear equation, remember, solving an equation, you want to do a solving process depending on the equation you're dealing with, because a linear equation solved differently from a quadratic and so on. So a linear equation, which is what you're going to deal with in this course, and a linear inequality, you want to get the variable x by itself, and think about, and you're going to use the addition property of equality in this particular case. So right now, to get the variable by itself, if you look at what you're doing on the left side, this says x plus 3. So right now I'm adding 3 to x. The opposite of adding 3 is to subtract 3. So you always do the opposite to obtain the variable by itself. So think about opposites. All right, so I'm going to use the addition property of equality. And remember, the addition property of equality says if you add or subtract a number from one side, you have to do the same thing to the other side to keep the equation balanced. So I'm going to subtract 3 from both sides, and you got to show both sides. Subtract 3, subtract 3. You must do one thing to each side. So if I subtract 3, I got to subtract 3 from each side. Notice they're listed twice. Once here, once here. Okay, so in the solving process, it's going to be the words combine like terms. So you're going to use those words quite a bit. Combine like terms, and we talked about like terms and combining like terms in a previous lesson. So if you look at these two terms here, which are constants, these are your constants, and you always can combine constants. A positive 3 and a negative 3, those are opposites. In a previous lesson, we talked about the fact that when you combine opposites, or when you add opposites, numbers that are opposite of each other, or terms that are opposite of each other, their sum is 0. All right, now you cross this out like this if you want to, but if you cross this out, you got to remember that crossing this out means that these two numbers added up is 0. So you really need to put that 0 there. Okay, that's important. Don't just cross things out without really indicating what's in its place. So in its place is 0. And now you can say x plus 0 is x, which is what you wanted to get. So remember, in the solution process, you're always going to end up with x equal a number, or it could be a number equal x. It does not matter which side the variable's on, but it will look like this. So in this, we're almost there. So I have x equal, and then whatever this 7 subtract 3 is. So 7 subtract 3 is 4. So I found the solution. All right, so you can always check 4 plus 3 is 7. All right, so you could have done this example by inspection, just looking at it. 4 plus 3 is 7, but remember, you have to show the work. All right, so that will be the direction, show the work. So you got to show you got to show subtract 3 from each side, and then you get x equal 4. So you have to show that you are using the addition property of equality. Just don't go from the equation to the solution. If it says show work, you must show what you're using. I am showing work here, subtract 3, because I'm using the addition property of equality. So that was the addition property of equality. Okay? So even though subtraction, you don't say subtraction property of equality. It's not called the subtraction property of equality. It's called the addition property of equality. It's because, remember, subtraction you can always rewrite as an addition problem by adding the opposite. So that's why we just call the addition property of equality. Now, to solve linear equations, you can't just use the addition property of equality. You also need to be able to use the multiplication property of equality. So let's talk about the multiplication property of equality. Okay, multiplication property of equality. All right, so basically it's just like the addition. So I can add. If I add a number to the left side, I have to add a number to the right side. If I subtract a number from the left side, I have to subtract a number from the right side. That's what it says. Multiplication property of equality, same thing. If, for instance, 4 is equal to 4. We know that. So that's a true statement. So that means this. If I multiply 4 by 5 on this side, then I've got to multiply this 4 by 5 as well. So what I do to one side, I have to do to the other. Okay, same thing with division. So I know 4 equals 4. So if I divide the left side by 2, then I must divide the right side by 2. Right? And then it's still a true statement. 20 equals 20, 4 equals 4, 2 equals 2. It's still a true statement. 4 divided by 2 is 2. Okay? All right, in terms of the property, though, the multiplication property of equality says this. If you have an equation that looks like this, so if this left side, which we'll call it A, is equal to the right side, which we'll call B, then multiplying the left side by C, if I multiply the left side by C, then I have to do the same thing to the right side. Now, we've got to make a note here that C cannot equal 0. So you can't multiply both sides of an equation by 0 or divide both sides by 0. All right, so if you divide by 0, you'll see in a little while that if you were to multiply or divide by 0, multiplying by 0, the equation turns out to be 0 equals 0 because you're multiplying something by 0. All right, so you cannot multiply by 0, divide by 0, and remember in the previous course, dividing by 0 is undefined. So that's why you can multiply by any number except 0. Any number except 0. All right, and again, if we have A equal B, then here I said I can multiply by C as long as C is not 0. I can multiply the left side or the right side by C. Here I can also divide. So in other words, I can divide the left side by C, but if I divide the left side by C, I have to divide the right side by C. So what I do to one side, I have to do the other. And again, as long as C does not equal 0. Okay, so basically what we said here is this. So both sides of an equation may be multiplied or divided by the same non-zero number. So C cannot equal 0. Non-zero number without changing the solution of the equation. Okay? All right. So let's look at an example. All right. Suppose we want to solve this equation. All right. So let's say we had this. So you want to solve this equation, so you want to find the solution. So you're going to do the solution process. Okay, number 1. Suppose we had 3x equal 12. 3x equal 12. All right, so let's look at what we have. I want to get the variable x by itself. So remember, when we talked about this, we said we want to eventually get x equal number or number x. So we want to find the solution. So when we get x by itself, this number right here is our solution. So I want to get x by itself. So think about when you read this. You read this as 3x, but remember that 3x means 3 times x. And so just like when we did this one here, we said that on the left side, I have x, but I'm adding 3. So the opposite of adding 3 is to subtract 3. And so you got to subtract 3 from both sides. What you do to one side, you have to do the other. Same thing applies here. Right now, let me go ahead and rewrite this over. Right now, I'm multiplying x by 3. The opposite of multiplying by 3 is divide by 3. So remember, though, that this 3 right here is called the coefficient. So this 3 is called the coefficient. All right, so my coefficient is 3. So I'm multiplying x by 3. The opposite of multiplying by 3 is to divide by 3. So I'm going to divide both sides by 3. What I do to one side, I do to the other. But remember this. When you cross this out, which you're going to do, and you're not going to put anything there, you have to put something there. You got to know what it is. Why are you crossing this out? Well, I'm crossing this out because 3 divided by 3 is 1. Now, don't confuse that with crossing this out where we got 0. This is 0 because I'm adding a 3 and a negative 3. 3 and a negative 3, a positive 3 and a negative 3 is 0. Here I'm dividing. 3 divided by 3 is 1. And 1 times x is x, which is what I wanted. I wanted x by itself. And so 12 divided by 3 is 4. So you found your solution. This is your solution. And we knew it was a solution because if you check it, 3 times 4 will give us 12. Okay, so let's look at number 2. All right, number 2, let's suppose we had negative 5x equals negative 20. So negative 5x equals negative 20. All right, so think about the coefficient. So remember this, you're multiplying here. So negative 5 times x. So you're trying to get x by itself. So remember, you got to show the work. Don't just go to the answer. You have to show this process. You got to show that you're dividing by 3. You have to be indicating that you're using the multiplication property of equality. All right, so my coefficient, remember this is your coefficient. So your coefficient is negative 5. That's your coefficient. And so right now I'm multiplying by negative 5. And so if I want to get the variable x by itself, I'm going to divide both sides by this coefficient. So your coefficient is a negative 5. Not a positive 5, a negative 5. And now negative 5 divided by negative 5 is 1. Remember, anything divided by itself is 1. As long as you're not dividing by 0. Okay? And so negative 5 divided by negative 5 is 1. 1 times x is x, which is what I wanted. And remember, though, a negative divided by negative is a positive. Okay, so that's why it's a positive x. And so negative 20 divided by negative 5 is a positive 4. So that's your solution here. So that's your solution. And you can check because negative 5 times 4 is a negative 20. A negative times a positive is a negative. Okay, so let's look at number 3. All right, number 3, you have negative x equals a positive 9. Negative x equals a positive 9. Now, in the previous two, most students, if not all of them, can understand what's happening here, can understand the solution process, why you're dividing by 3, why you're dividing by negative 5. Here, this kind of throws students off because you don't see a number there. But remember, if there's no number there, it's understood to be a 1. So in this case, it's a negative 1. So it may help you if you rewrite a negative x as negative 1 times x, just like this. And so that's equal to 9, a positive 9. All right, so it does help if you do this. And so remember, you're trying to get the variable x by itself, just like you did here. So right now, this is a negative 1x, or a negative x, so it's not x. So right now, I'm multiplying this x by negative 1, so my coefficient is negative 1. So remember the coefficient, this is your coefficient here, negative 1. So I'm going to divide both sides by negative 1, just like this. So that's what you're going to show, divide by negative 1. And so negative 1 divided by negative 1 is a 1. So remember, I'm using the idea of simplify here. I'm simplifying. So here I simplified. So negative 5 divided by negative 5 is 1. So you're simplifying. That's what's happening here. And so 1 times x is x. And then when I simplify the right side, positive 9 divided by negative 1 is a negative 9. So that's your solution. Okay? All right. Number 4. All right, now look at number 4. Number 4. So number 4, we have 3/5 x is equal to 18. So 3/5 x is equal to 18. So the coefficient here is 3/5. So that's your coefficient. And we're going to do this in a couple ways. So the first way will be the same way we did these. So my coefficient was 3. I divided both sides by 3. My coefficient was negative 5. I divided both sides by negative 5. My coefficient is negative 1. I divided both sides by negative 1. Here my coefficient is 3/5. This says 3/5 times x. So my coefficient is 3/5. So I'm going to divide both sides by 3/5. That's what I'm going to do. All right, but before I do that, let's kind of review something from a previous course. And that's where you had to divide fractions. So let's talk about dividing fractions, previous course. So if you had 2/3 divided by 4/5, let's suppose you had that. 2/3 divided by 4/5. So remember, when you're dividing fractions, you're going to change this division right here to multiplication problem. So remember, you can always write a division problem as a multiplication problem. And to do that, you're going to take the fraction that's in the numerator, which is 2/3, and you're going to multiply by the reciprocal of the fraction that's in the denominator. So the reciprocal of 4/5 is 5/4. So it looks like this. So this right here is equivalent to this expression. So I changed this division to multiplication. I changed this division to multiplication by, you take the fraction that's in the numerator, multiply by the reciprocal of the fraction that's in the denominator. And I'm going to go ahead and reduce. So usually helpful if you reduce first rather than multiply first and then reduce. So try and reduce first. 2 and a 2 is 1. 2 and a 4 is 2. So that's about all I can do in terms of reducing. And so now I'm going to multiply the numerators out and multiply the denominators out. 1 times 5 is 5. 3 times 2 is 6. Okay? All right, so now let's look at this. Again, right now my coefficient is 3/5, so this says 3/5 times x. The opposite of multiplying by 3/5 is to divide by 3/5. So this is what it looks like, divide by 3/5. And then remember, 3/5 divided by 3/5 is 1. Anything divided by itself is 1 as long as you're not dividing by 0. 1 times x is x. All right, let's talk about this. So we're going to simplify this just like we did this. All right, so remember 18 is the same thing as saying 18 divided by 1. So I get 18 divided by 1 times, remember division, you're going to change to multiplication. The reciprocal of 3/5. So the reciprocal of 3/5 is 5/3. That's the reciprocal of 3/5. And then I'm going to reduce. I'm not going to multiply first, although you can, and then reduce. It's quicker, more efficient to reduce first. So 3 and a 3 is 1. 3 and a 18 is 6. So that's what I have. And I'm going to multiply the numerators. I'm going to multiply the denominators. 6 times 5 is 30. 1 times 1 is 1. And then simplifying this, 30 divided by 1 is 30. So that's your solution. So my solution is 30. Okay, that's your solution. That's what you just found, your solution. And this is your solution process, your solving process. So you can always check this. If you want to check this, go back to the original. You always go back to the original. You're going to say 3/5 times x. And I'm saying my solution is 30, so it's 3/5 times 30. And I want to see, question mark, I want to see if that's equal to 18. I'm going to go ahead and write 30 as 30 over 1. Okay, now to multiply these two fractions, again, I want to see if this product is 18. I'm going to go ahead and simplify first. 5 into 5 is 1. 5 into 30 is 6. And then 3 times 6 is 18. So it does work. Okay? All right, now let's do number 4. So I'm going to go ahead and write number 4 as this one, as this again. I'll just go ahead and rewrite it. But now we're going to use this idea. Okay? Now, it does not matter which approach you use when you have the coefficient being a fraction like this. It does not matter. But another way you can do this is when you have a coefficient that's a fraction, like this, you can just multiply both sides, by the reciprocal of the coefficient. Okay, multiply both sides by the reciprocal of the coefficient, which kind of relates to what we did here also. I mean, it is related to this. Because remember, when you divide both sides by 3/5, right here, basically what you're doing is you're taking 18 and you're multiplying it by the reciprocal of that coefficient. That's what you're doing. So in other words, it'll look like this, though. So I'm going to go ahead and rewrite this over and just show you what it's going to look like. Again, it does not matter which approach you take. Many students prefer to use this. Sometimes, though, they'll do this approach here. All right, so the coefficient is 3/5. So if I want this, remember, you want this to be a 1, okay? So remember, the multiplicative inverse of 3/5 is its reciprocal, so 5/3. So in other words, if I multiply this side by 5/3, I've got to multiply this side by 5/3. All right, now notice, I want you to notice before we go any further, this right here, this right side is this right here. See it? Same thing. 18 times 5/3. 18 times 5/3. Now this, though, I want you to notice something. This right here that I'm circling. If I reduce 5 into 5 is 1, 5 into 5 is 1, 3 into 3 is 3, 3 into 3 is 1. This whole product right here is 1, which kind of makes sense from the previous lesson. Remember in the previous lesson, when you multiply reciprocals, two numbers that are reciprocals of each other, you get 1. So remember, 2/5 times 5/2 is 10 over 10, which is 1. So remember that? Remember all that? Okay. So I want you to notice that if you multiply both sides by the coefficient, the reciprocal of the coefficient, you'll still get the same answer. But it would have to look like this. If this is 3/5, you're going to say times 5/3 on both sides. And notice that this is 1 right here. That's 1. 1 times x is x. And then you just got to reduce this. So I'm going to write this as 18 over 1. 3 into 3 is 1. 3 into 18 is 6. And 6 over 1 is 6. 5 over 1 is 5. 6 times 5 is 30. Okay, so you get the same answer. All right, number 6. Okay, so number 6, let's suppose we had this. Suppose we had 3/4, actually let's do this one. 1/6 d is equal to 1/2. 1/6 d is equal to 1/2. All right, and we can do it both ways here, but at one point I'm not going to do it both ways because of time constraints. So the first approach is to recognize that this is a product right here. 1/6 d means 1/6 times d. And also recognize that 1/6 is the coefficient. You need to recognize that. All right, and so if you want to do that first approach where you divide both sides by the coefficient, that's fine. So the coefficient is 1/6. So let me go ahead and rewrite this over. So I'm going to divide both sides by 1/6, just like this. Okay, no big deal. 1/6 divided by 1/6 is 1. 1 times d is d. All right, let's talk about this. So I have 1/2 divided by 1/6. So I got to change this division to multiplication. So remember, when you divide fractions, you have to write as a multiplication problem. So it's the fraction that's in the numerator, which is 1/2, times the reciprocal of the fraction that's in the denominator. So the reciprocal of 1/6 is 6 over 1. And then you can multiply first. 1 times 6 is 6. 2 times 1 is 2, and you get 3. And then reduce last. Or if you want to, you can reduce first. 2 is 1. 2 into 6 is 3. And then multiply. 1 times 3 is 3. So I get d is 3. Okay? D is 3. And it kind of makes sense because if you check this, so I'm going to go back to the original. So 1/6 times d, my solution, I'm saying is 3. So that's 3 over 1. And I want to see if that's going to equal 1/2. That's the question. All right, well, let's look at this. So let's multiply these two fractions. So I'm going to go ahead and reduce first. 3 into 3 is 1. 3 into 6 is 2. And notice 1 times 1 is 1. 2 times 1 is 2. So I do get 1/2. All right, number 7. Okay, number 7, suppose we had this. Suppose we had a divided by 6 is equal to a negative 2. A divided by 6 equals a negative 2. All right, now, many students are going to mess up here, and they're going to say that the coefficient is 1. The coefficient of a is not 1. Be careful. They're going to say 1 because they see this 1a here. But that's not the coefficient. The coefficient of a is not 1. You got to be careful. You have to recognize, see this right here? You have to recognize that a over 6 is the same thing as saying 1, see that's a 1 right here, 1/6. 1/6. So that's 1/6a. That is this. It is important when you're asked, if you have this right here and you're asked what's the coefficient of a, you don't say 1 because that's the wrong answer. The coefficient of a is 1/6. The numerator, you see the denominator here, 1/6. That's the coefficient of a. And make sure you understand that those do the same thing. Okay, look at this for a moment. I just rewrote this. You need to understand that this is this. So here's how you can tell. Remember, a is the same thing as a over 1. And so 1 times a, if I multiply the numerators, 1 times a is a, and then if I multiply the two denominators, 6 times 1 is 6, and notice you get a over 6, which is what this is. Okay, so you got to, whenever you have something like this that looks like this, and you think the coefficient of 1, you got to step back, and you got to say, all right, let me go ahead and rewrite it like this. All right, so I get 1/6a equals a negative 2. All right, I'm going to go ahead and you can do it like we did here, where you divide both sides by 1/6, or you can go ahead and multiply both sides by the reciprocal of the coefficient. Let's go ahead and do it by multiplying both sides by the reciprocal of the coefficient. So we'll go ahead and rewrite this over. All right, so the reciprocal of 1/6 is 6 over 1. But what I do to the left, I've got to do to the right, so 6 over 1. Okay? And I want you to recognize that when we multiply both sides by the reciprocal of the coefficient, these two numbers here, 6 over 1 and 1/6, those two fractions, those two numbers are reciprocals, or multiplicative inverses. They're reciprocals. So that means when you multiply those two numbers, you're going to get the product of 1. It kind of makes sense because look, 6 into 6 is 1, 6 into 6 is 1, 1 times 1 is 1, 1 times 1 is 1, and you get a 1. So this whole thing is 1. And so 1 times a is a, equal. And then notice that's just 6 over 1 is just 6. So negative 2 times 6 is a negative 12. So there's your answer. There's your solution, negative 12. Okay. Now you could have, in this case, if you wanted to, I'm going to rewrite this. That's 1/6 times a equals negative 2. You could have divided both sides by 1/6. It does not matter. 1/6. It does not matter. You get the same answer. Because look, 1/6 divided by 1/6 is 1, just like we did here. All right. Now over here, though, this right here, you got to go off to the side and figure out what that is. And 1 times a is a. So you got to go off to the side and figure out what that is. So negative 2 is the same thing to say negative 2 over 1 times, change the division multiplication. So times the reciprocal of the fractions in the denominator. So the reciprocal of 1/6 is 6 over 1. So I got negative 2 times 6 is negative 12. 1 times 1 is 1, which simplified or reduced is negative 12. So this is negative 12. So again, it does not matter which approach you take. Okay, so let's look at this, number 8. Now, sometimes you'll end up with a decimal. So if you have a decimal, just use your calculator. So let's look at this for a moment. All right, so look at this. So 1.7x equals 10.71. So we have. So again, the coefficient is, so remember, this is your coefficient, whatever you multiply the variable by. So that's your coefficient. So right now, multiplying by 1.7, I'm going to go ahead and rewrite this over. And so the opposite of multiplying by 1.7 is to divide by 1.7. Now remember, mathematically, you could say 1.7, but mathematically, the correct way of saying this is 1 7/10. So I'm going to divide both sides by 1 7/10. Remember, place value from last semester. That's what I'm talking about here, place value. All right, so 1 7/10 divided by itself, that is 1. 1 times x is x, equal. And then on your calculator, you just say, just use your calculator. So you're saying 10.71. So 10 and 71/100ths, that's what that is, divided by 1 7/10, and you get 6 3/10. So you get 6.3. So that's your solution. And you can check this if you want to check. It's easy to check with the calculator. Watch. 1.7 times x, I'm saying my solution is 6.3. And you want to see if that product is 10.71. That's what you're trying to find. So in your calculator, just say 1.7 times 6.3 equal, and you get, notice, 10.71. Okay, so that's 10.71, and that's the same thing. Okay, so that's going to take care of this lesson on using the multiplication property of equality. And in the next lesson, dealing with this particular part again, is going to be a combination of the multiplication property of equality and the addition property of equality. Okay, so we're going to extend this further.